Let's see here. We got 13.5 trig ratios of common angles. And I hadn't underlined a single thing on here. You're supposed to do these by drawing. So number 2 looks kind of interesting. 2 pi, if you do your little formula or whatever, if you memorize, however you do it. Oops, it's supposed to be 180 over pi. Some math teacher I'm being right now. 2 pi is 360 degrees. Hopefully you've memorized this. So you're actually finding the secant of 360 degrees. Now, you can't draw a triangle. 360 degrees would do one full rotation and end up right here. That's where it would be. It would rotate 360 degrees. It'd be right there. Can't do anything with it. You can't draw a triangle. So what you have to do is you draw a unit circle. Now, when you draw a unit circle, you have a radius of 1. So this is the ordered pair 1, 0. Why is that important? Well, because you take a circular approach. On the circular approach, cosine is x over r, so its reciprocal secant is r over x. Ta-da! So I'm just going to go ahead and plug this in. Here's my x, here's my radius. The secant of 360 degrees would be 1 over 1, which is 1. I'm pretty confident your calculator can actually do this one correctly because there's only one answer. That's it. There's only one place where x is 1 on a unit circle. Because the ordered pair was 0, 1, negative 1, 0. I guess I should write that down for clarification. Oh, no, never mind. We were right there. You don't have a secant button on a TI-84, but you do have a cosine. Remember, secant is 1 over cosine. So you can actually type 1 divided by the cosine of 360, and there she is. You can do it in TI-84. What else looks interesting on this front page? Maybe number 5. Let's just go straight down. Tangent 11 pi over 6. So you're going to have to figure out what 11 pi over 6 is as a degree. You're going to multiply by, what, 180 over pi? I believe that's right. And 11 pi over 6 should be 330 degrees when everything is said and done. I feel like that's right. Because that becomes a 30, 11 30s is 330, pi's cancel. It's a 330 degree angle. And you are supposed to do these by drawing. So you draw a 330 degree angle, and then you figure out what's left. What's left is 60 degrees. So a pattern that I was trying to teach in your notes today, and that's what you have to refer back to, are these special patterns. The pattern I teach for drawing triangles on a grid is as easy as 1, 2, root 3. 1 is opposite 30 degrees, 2 is the hypotenuse, root 3 is the 60 degree angle. So opposite of a 60 is a root 3. It is falling, direction matters, and by the way, ASTC, tangent is negative. If you're in that quadrant, you're negative. And adjacent to a 60 is a 1, hypotenuse is 2. So now I can do my tangent ratio. Tangent by triangles is SOHCAHTOA, so the tangent of 11 pi over 6 would be opposite over adjacent, negative root 3 over 1, or just negative root 3. Six, the cot, or cotangent of 3 pi over 4. 3 pi over 4, when you convert into a degree, is a 135 degree angle. So she rotates into quadrant 2, and what's left is a reference of 45 degrees. So the pattern I would have talked about in your notes would be 1, 1, root 2. Adjacent to either 45-degree angle wherever you're looking is a 1. Opposite is a 1. Root 2 is a hypotenuse. Now direction matters. That 1 went left. By the way, ASTC, you're in quadrant 2. Only sine and cosecant are positive. The answer is negative. That's what ASTC gives you. It gives you a check too. But anyways, I've got what I need. So I'm going to find the cotangent of 3 pi over 4. Cotangent is reciprocal of tangent. Tangent is opposite over adjacent. So cotangent is AL. So adjacent is a -1, opposite is a 1. There's your answer. -1. Let's do a reciprocal, or sorry, let's do a quadrantal. This is pi over 2. Pi over 2 would rotate here. It's a 90-degree angle. It's quadrantal. And just like on number 2, you have to do the unit circle approach. Now you can actually you can do anything. You could use a circle of radius 6, 12, it doesn't matter. But we use a unit circle because we have a radius of 1. So let me fatten this out a little bit. And here's my radius. She's 1. I define her to be that way. This would be 90 degrees. Pi over 2, by the way, is 180 over 2. That's 90 degrees. And the ordered pair associated with it is going to be 0, 1. All right, shouldn't be a problem there. If you think about the circular approach, the sine of an angle is going to be y over r, which means the cosecant of an angle is going to be r over y. So the y value is 1, radius is 1, we get a 1. Ta-da! All right, done with that one. Let's see here. I don't want to do too many of these. The hardest one in here is probably 10, because the ratio is negative. So theta is the arc cosine of -1/2. I don't know why that looks the way it does. It's supposed to be theta. I have no idea what happened. It's there too. Theta is the arc cosine of -1/2. This ratio is negative. Cosine ratio is negative in quadrant 2 and 3. So I'm going to draw a triangle in quadrant 2. It's not really there, by the way. This is the angle. That's the angle. This is the triangle I use. And the cosine ratio is adjacent over hypotenuse. So adjacent to theta prime is a -1, hypotenuse is 2. Does it look familiar? It should. It looks to me like a 30, 60, 90. That's what she looks like. She looks like a 30, 60, 90. 1, 2, root 3. What you're missing here is the root of 3 that goes up. Now, root 3 is across from a 60-degree angle. So theta prime is 60 degrees. That means that theta, the first theta, is 180 minus 60 degrees, which is 120 degrees. Now, you're supposed to give that as a pi rad. The disclaimer over here is 0 to 2 pi. So if you hadn't memorized it, you're going to have to do pi over 180. Anyways, it's 2 pi over 3. That's one answer. The other place that you were allowed to draw was in quadrant 4. And so I don't clutter up my diagram here. I'm just going to put it in quadrant 4. I'm still following the cosine ratio. Here's theta prime. Adjacent is a -1, hypotenuse is 2, and what's missing here is actually a negative root 3 because you're falling, but that doesn't change anything. It still holds that a root of 3 is directly opposite of an angle that measures 60 degrees. And then you think about the actual rotation. The actual rotation was 180 plus 60. So the second theta is 240 degrees, which as a pi rad is 4 pi over 3. There is 10 in all of 10's glory. Let's see here. Where's the back side of this? I take this back. This is the hardest one on here. Theta is the arctangent of negative root 3 over 3. Why is that so hard? Because that is a radical that's been cleaned up. That is actually negative 1 over root 3. Because you multiply by root 3 over root 3, and you get negative root 3 over 3. That's why it's so hard. Now, the odds of you knowing that are slim to none, even after I've shown it to you. When you draw this thing, this, by the way, is negative. All schools tortured children. When you draw this thing, the tangent ratio is negative here and here. When I draw this triangle, it's not going to be apparent to me what angle measure I have. But opposite over adjacent, well, the root 3 is actually positive because it's rising. The 3 is the negative because a positive divided by a negative is negative. What's missing? You go off and you do a little bit of Pythagorean theorem, and I think what you'll discover is that you're missing maybe, I don't know. We'll see. We do what? 3 squared plus root 3 squared, root 12. Root 12 is 4 times 3, so this is 2 root 3. This is a 30, 60, 90 pattern. The hypotenuse is twice the short leg. Additionally, if you take the short leg, root 3, and you multiply it by root 3, you get that one. So the angle here, the reference angle, is 30 degrees, which means the actual angle was 150. That's one of the answers. There was 2 of them. There's always 2 of them. There is also the angle down here in quadrant 4. Now what you now know is that the reference is 30 degrees. To get there, you travel 330. So we have a theta 1 being 150. We have a theta 2 being 330. 150 degrees is 5 pi over 6. 330 degrees is going to be 11 pi over 6. All right, solving. Oh man, I put 15. Ooh, 15's hard. 15 has 4 answers. That 2 in there speeds this function up, makes it happen twice. This one only has 2. This one only has 2. Those guys only have 2 answers. That's all they have. So 15 has got the hard one, so I'll do 15. I am going to divide the 3 out, and I have the tangent of twice x is negative root 3 over 3. What I'm going to do is I'm going to figure out where this is true, and by the way, that was up here, wasn't it? Notice this? Isn't that the same problem except there's a 2x in here? It turns out that 2x is the arctangent of negative root 3 over 3. So you've actually already got 2 of your answers for the most part for you. These guys return these answers here, 150 and 330. Or, because we're in radians, 5 pi over 6 and 11 pi over 6. So we'll just use degrees, we'll convert. So 2x equals 150, or 2x equals 330. This is 2x, sorry, x equals 75 degrees, and this is x equals 165 degrees. There's 2 of your answers. 75 degrees as a pi rad is going to be 5 pi over 12. 165 degrees as a pi rad is going to be 11 pi over 12. Now, why did I say that there were more than one answer? Because there is, I think. 75 degrees is going to be right here. I'm just checking myself. There may not be more than one answer. Oh, this is the tangent function. Sorry, that only works for cosine and sine. It only had two answers. Nope, nope, nope. There's four answers. It took me a second. This is beyond the scope of algebra 2, but the tangent function has a period of pi. The degree of separation between these two answers is pi. That's what it is. If you take your 75 degrees, it's not pi. If you go back to the original two answers, they separated by 180 degrees. That's what they were separated by, 180 degrees. So the question is what can I add to this thing? You know what? I'm not going to do this. The other two answers are really beyond the scope of algebra 2, and I don't want to confuse you. I don't want to confuse you. So, good enough for algebra 2. Good enough. All right? I don't need to confuse you. Trig is hard enough without me trying to throw actual trigonometry in it. Let's see, what else do I feel like doing? I kind of want to do 17, but I kind of don't. That says squared. So let's see if you can figure that one out. 18, write a recursive rule for the sequence. 8, 5, 7 halves, find the fifth term. You have to define the first term. The first term is 8. It has to be defined. Now, what is the rule that's going on here? What on earth did I come up with when I made this sequence? I believe I divided by 2 and added 1. I think if I take 8, cut it in half, I get 4. And if I add 1, I get 5. Oops, sorry, that one. So if I take 5 and cut it in half, I get 2.5. If I add 1, I get 3.5, which is 7 halves. So yeah, that's apparently whatever I was thinking whenever I made this sheet. Cut it in half, add 1. So the rule is to take the previous term, a sub n minus 1, cut it in half, and add 1. So now you're supposed to find the fifth term. So you've got the first, second, third. The fourth term would be 7 halves, cut in half, add 1. If you take 7 halves and cut it in half, you get 7 quarters. If you add 1, which is 4 fourths, you get 11 fourths. Notice I'm not pushing any buttons? You don't have to push buttons. I know a lot of you guys will. Whatever, you're just robbing yourself. The next one is 11 quarters, cut in half, add 1. If you take 11 quarters and cut it in half, 4 times 2 is 8, you have 11 eighths. And you're going to add to that, not 1, but 8 eighths, which is 19 eighths. Whoops, that was intermediate. There's the fifth term. And I am like ridiculously tired, so I'm done. The rest of it's on you. And if you can't figure it out, all one has to do is ask. That's all one ever has to do. I might yell at you a little bit, but I'll help you.